Hi everyone. In this video, we are going to walk through how to set up, simulate, and analyze a Verilog project using Crucible CLI by Ignytion. Let's kick things off by initializing our project with a simple igny init command. Ignytion springs to life, ready to set up our development environment. Next, we'll create a dedicated environment for our 7-segment decoder project. The environment is created instantly, giving us an isolated space to manage our tools and dependencies. Let's spin up a workspace, binding it directly to our newly created environment with a single command. The workspace is ready, and you can see the folder appear instantly in our File Explorer. With our project structure in place, we're set up for a streamlined workflow. Let's navigate into our new workspace directory. The terminal updates to reflect our new location, right inside the project folder. And we're ready for the next phase of our setup. Our workspace is now initialized and ready to go. Next, let's install the Verilog tools we'll need to compile our design. Next, we bring in our simulation engine by running igny tool install Icarus Verilog. And just like that, Icarus Verilog is installed and automatically bound to our environment, ready for compilation. Let's add our waveform viewer with igny tool install GTKWave. GTKWave is installed in seconds, giving us everything we need to visualize our simulation results. With both tools bound to our 7-segment decoder environment, our toolchain is fully configured and ready to go. Let's dive into the source code for the 7-segment decoder. Let's take a quick look at the source files that power this project. On the left terminal, find and open up the core design file, 7-segment decoder. Here we can review the Verilog logic that defines exactly how our 7-segment decoder behaves. Next, we jump into the testbench file. This is where we define the test scenarios that will rigorously validate our design's functionality during simulation. With the source code reviewed, we head back to the terminal to bring this design to life. Now let's compile the design and run the simulation to see the decoder in action. Let's clear the terminal for a clean workspace before we begin the simulation. We leverage Crucible CLI to run Icarus Verilog directly, compiling both our design and testbench into a single simulation file. And just like that, our compiled simulation file is ready to execute. With compilation complete, we're set up to bring our decoder to life. Next, we run the simulation using VVP through the igny run VVP command. The simulation executes instantly, confirming our test passed and generating the VCD file we'll use for waveform analysis. With our simulation complete, it's time to dive into the results visually. A single command launches GTKWave directly with our generated VCD file. And just like that, the GTKWave application opens, ready for analysis. We can quickly append all the relevant signals to our waveform viewer to get a complete picture of the design's behavior. A quick zoom fit gives us the entire simulation timeline at a glance. For deeper insight, let's switch the 7-segment output signal format to binary, which is for verifying each individual segment of the display. Instantly, the waveform updates, revealing the precise binary patterns driving our 7-segment decoder. With our design verified, close GTKWave and head back to the terminal. Now let's properly exit the development environment. Run igny exit command to leave the Crucible environment, and that wraps up exiting the environment cleanly. The 7-segment decoder project walks through compiling the Verilog code, simulating it, and checking the waveform through VS Code or any other IDE.